Welcome back to our series of individual videos on new 7 tools. In this video, we are going to understand yet another new 7 tool deeply through some examples. As in the past, each tool is explained again with many examples in separate videos. In this video, we are going to see the 6th tool, Process Decision Program Chart, which is also known as PDPC method. Let us recall our learning on PDPC diagram or Process Decision Program Chart. The Process Decision Program Chart, also known as PDPC method, logically anticipates the possibility of actions or events which might go wrong in a plan under development. So it will anticipate what can go wrong in a plan or in an objective, and it suggests appropriate countermeasures to overcome or offset such potential problems. So by identifying problems, it also gives alternate countermeasures. So by utilizing PDPC method, we can circumvent the problems. We will be able to overcome the problems through several alternate actions or plans and achieve the overall objective of the plan or project. So this method is for mapping out every conceivable event. So by doing this method, we are identifying whatever can go wrong and contingency that can occur when moving from a problem statement to possible solutions. When we are executing a plan, what all the things can go wrong? If such things happen, what can we do? So PDPC has to be prepared before implementing a plan. So essentially, before implementing an objective or a plan, we have to do PDPC. Why? For achieving an objective flawlessly. Especially when the plan is complex, when the plan involves a lot of actions and has large scope of actions, or when the plan has to be completed as per schedule. If there is a schedule, if it has to be completed, then we have to definitely do PDPC. Or when the cost of a failure of implementing the plan as per schedule is high. If you are not able to do as per the plan and if the cost is going to be high, essentially we have to do PDPC. Let us recall our learning on structure of the PDPC diagram. Structurally, the PDPC chart resembles a tree diagram, which we have already seen, which is one of the new 7 tools, with tasks broken down in the hierarchical sequence, that is from the starting point to end point in the form of hierarchical sequence, along with a few identified potential risks. So in each stage, what are all the potential risks and appropriate countermeasures depicted in separate boxes, especially for bottom level tasks of the tree diagram. Okay, so different shaped boxes are used to represent the identified potential problems or risks and corresponding countermeasures. Since some of the risks may be uncertain, the countermeasures may be shown as clouds. Since some uncertain situations may or may not happen, we may show it as clouds. In this case, we are seeing a typical PDPC chart in the adjoining figure. So this is the project objective or target to be achieved. Obviously, it is broken down into various planned actions. This is one action, this is one action, this is one action. So, for example, if this action is taking place, what will be the next level actions? These are all coming as steps. So the actions are these things. The next level steps for each action are, this is the next level action, this is the next level action, this is the next level action. So what will be done or what can go wrong? So these are all the potential problems. Similarly, for this action, these are all the potential problems. So if that happens, what can we do to overcome that? This is the countermeasure 1. This is the countermeasure 2. This is the countermeasure 3, like that. So typically, the PDPC diagram resembles a tree diagram. Let us understand the PDPC diagram deeply with some examples. Let us analyze the adjoining PDPC diagram example, where a company has taken an objective of installing a new computer system. So the company's objective is to install a new computer system. So the top management and IT function have identified the actions. So these are all the actions. What are all the actions they have identified? Analyzing the needs, configuring the system, installing the hardware, and training the users, etc. are the actions to realize the organizational objective. Now, let us see typically the next step of each action. As an example, let us list the steps to be done to complete the action of training the users. So, we are considering this action of training the users. What are all the steps? Scheduling training sessions, developing training manuals, and conducting training classes, etc. These are all the steps. Okay. What to do in case of insufficient staff for training? Okay, so suppose the staff is insufficient. What could be the countermeasures? Overtime or assistance from temporary help. So these are all the possible countermeasures. So if this problem happens, we can overcome that either by giving overtime or taking the help from the temporary staff. So these are all the essential things of a PDPC diagram. Similarly, if not enough time is available for developing training manuals, what can we do? We can come out with a countermeasure of external trainer hiring. So we can hire an external trainer and then we can overcome the problem of not enough time. This is the PDPC diagram for achieving the objective of installing a new computer system. Let us understand PDPC diagram deeply with some more examples. Here, let us analyze another PDPC diagram example showing various actions for implementing SPC. SPC is Statistical Process Control in compressor machining cell. In a manufacturing cell which is manufacturing compressors, machining compressors. So they wanted to implement SPC and what are all the problems anticipated and their countermeasures. They are all shown in this PDPC diagram. Okay, so some of the abbreviations like QA stands for quality assurance, ME stands for manufacturing engineering. So the green circles are feasible actions and not all the countermeasures will be possible. So not feasible countermeasures are given by red color into mark. Okay, so now the objective is implement SPC in compressor machining cell. So what are all the actions? Review and improve the quality assurance system. Another action is review and improve metrology system. Next is improve operator skill and competency. So what are all the steps for reviewing and improving quality assurance system? Prepare updated control plans, institute robust process audit system. So what can go wrong in preparing updated control plans? More time consumption due to increased documentation. So what could be the possible countermeasure? Utilize the services of ME, manufacturing engineering people apart from quality assurance functional staff. Similarly, institute robust process audit system. Step, what can go wrong? Excess load for quality assurance staff. So what could be the countermeasures? Two countermeasures have been identified. One is utilize the services of team leaders and the line leaders of manufacturing function till audit process is streamlined. This is a possible countermeasure. Whereas another countermeasure, recruit new QA persons urgently. This is not possible because it may take some more time. The situation is very urgent. So this is not a possible countermeasure. Similarly, review and improve metrology system action. Two steps are there. Procure new gauges, implement robust data acquisition system. So what can go wrong in procuring new gauges? Delay in arrival of gauges. So what could be the countermeasure? Use spare gauges in metrology room till new gauges are arriving. Similarly, implementing robust data acquisition system. What could be the anticipated problem? Delaying installing dedicated data acquisition system. So what could be the countermeasure which is possible? Outsource the data acquisition process for the time being. Similarly, for the step of finalizing skill set and training process, the possible problem is non-availability of in-house training faculty. So what could be the possible countermeasure? Utilize the services of external agencies. Similarly, for training and certifying operator step, the possible problem could be operators feel increased workload. So what could be the countermeasure which is feasible? Sensitize the operators with the support of employee union. So by doing this PDPC, we are able to identify potential problems, and we have also come out with the possible solutions or possible countermeasures for implementing the objective of implementing SPC in compressor machining cell. These are all the various steps we have seen in doing this PDPC diagram. Let us see another example. Let us analyze another PDPC chart showing the various actions for digitization of all R&D drawings and documents. So what is the objective? Digitalization of drawings of R&D function. So what are all the feasible actions? They are given in green color circle. So what are all the actions? Scanning manual and paper drawings, moving the digital drawings to common server, establishment of internet to access the drawings. These are all the actions. So what are all the steps for each? Scan the paper drawings and move the digitized drawing files to the server for this action. Prepare the list of available digital drawings and collect the digital drawings from individual workstations and move to the server. These are all the actions for, these are all the steps for moving the digital drawings to common server. Similarly, for this action, establishment of intranet to access the drawings, develop and launch a user-friendly intranet to access all R&D drawings and documents. So, in the case of potential problems for the scanning the paper drawings, what could be the problem? Inadequate rate of scanning and delay in scanning process. So what could be the solution? Employ contractor having heavy duty scanner facility so that we will be able to scan easily. Similarly, for this step of moving the digitalized drawing files to the server, what could be the problem? Excess load for IT function staff. So what could be the solution? Outsource the activities of scanning and moving the digitized files to server. Similarly, in the step of preparing the list of available drawings, what could go wrong? Error in the list of available drawings, digital drawings. So what could be the solution? Countermeasure, institute a team to correct the errors with the participation of all drafting persons. Similarly, for collecting the digital drawings from individual workstations and move to the server, what could be the possible failure? Possibility of some drawings not available in the workstations. So what could be the possible countermeasure? Utilize the services of external people to recreate the missing drawings. Similarly, for developing and launching a user-friendly intranet to access all R&D drawings and documents, what could go wrong? Lack of competency of IT team on web designing. So what could be the possible countermeasure? Utilize the services of external agencies for intranet design. Similarly, for the anticipated problem of the intranet is not comprehensive and user-friendly, we can come out with a countermeasure, form a cross-functional team to give recommendation of the intranet requirements. So, if you have to successfully implement the plan of digitization of drawings of R&D function, these are all the possible actions and these are all the steps. These are the potential failures which can affect the objective, and then these could be the possible countermeasures. Thus, this is the comprehensive PDPC diagram for achieving an objective of an organization. So, in summary, the process decision program chart or PDPC is a new management planning tool that systematically defines what might go wrong in a plan under development. Accordingly, countermeasures are developed to prevent or offset these problems. So, by using PDPC, you can either revise the plan to avoid the problems or be ready with the best response when a problem occurs. PDPC diagram method has to be used when before implementing a plan, especially when the plan is large and complex, when the plan must be completed on schedule, when the price of failure is very, very high. So these are all the situations when you doesn't essentially have to use PDPC diagram. Thank you for your active participation.